everyone, and the goal of this video is to be able to factor polynomials completely. So throughout this video we're going to be talking about what that means and how to go about doing that. So let's take a look at, first of all, what is factoring. So factoring is when you turn a sum into a product. Most of the time it's helpful just to be able to see an example. So an example of what this means is when we take something like x squared plus 7x plus 10. That's a sum because it's got things being added. And we're going to turn it into something that's equal, but it's a product. So it's things being multiplied. And so in our case, for this one, it would be x plus 2 times x plus 5. That is an equivalent statement, but it's written as a product because it's being multiplied instead of being added. Okay? So factoring is really writing something as a product. That's the official name, but that's the official definition, excuse me. Write something as a product. So that's how you originally learned factoring when you were a young child, when you were learning about multiplication. You rewrote things as products. That's what factoring means. In our terms, we're going to be talking about taking things that are sums and turning them into products. So why do we need to be able to factor? Factoring tells us some key, factoring helps us see key characteristics of functions. Now, a lot of this you've seen before, what you'll see in pre-calc this year, much of it you've seen before. So an example of a function written as a product, x minus 5 times x plus 2 times x minus 3, all of that times 2 in the front there. This tells me key information about this particular function. It tells me actually the zeros, if you remember the zeros, can be seen in each of these factors. The 2 would be our stretch factor, how much the polynomial is being stretched. If it was a negative 2, then we would have a flipped polynomial. So these are all things you've somewhat seen in the past, but we're going to solidify them this year. And so factoring will be a key thing we're going to use. We're going to use it for trigonometry, we're going to use it for polynomials, for rational functions, for a countless number of operations we need to know how to factor. So let's review how we do this. Example 1. In example 1, the first thing that I want to remind you is you always want to look for a common factor. So when I look at all three of these terms, you should see something they all have in common. And one of the things they have in common is they all have an x. Every single one of them has at least one x that can be factored out. The next thing they have in common is that each of these numbers is divisible by 2. The 4, the 10, and the 24 are all divisible by 2. So what I'm going to do is I'm going to factor that out to start my problem. So I'm going to take a 2x out because 2x goes into each of those. 2x times 2x squared equals 4x to the third. So I'm thinking about what number times 2x will give me 4x to the third. And I'm going to keep doing that for each term. So 2x times 5x will give me 10x squared. And then it'll be a minus 12. Because 2x, again, 2x times negative 12 will give you negative 24x. So this is my factored form so far. Now, I'm not necessarily factored completely, but I've definitely started the process. So you always want to check for a common factor first. Now, our next step is to factor the rest of this, 2x squared plus 5x minus 12, more completely. So we want to check and see if that's factorable. So the 2x is going to stay, but what we're checking for is if the polynomial, in this case the quadratic, because it's got an x squared as the highest degree, if that can be factored further. What you should remember from the past is we do this by creating a diamond problem generic rectangle. So we're going to take these parts because it's a quadratic and we're going to plug them in where they belong. So 2x squared and the negative 12. So I'm pulling these from here and here. That's where I got those. And remember the 5x goes in the sum portion of your diamond problem. Because these two corners that we're missing here have to add up to 5x, because altogether they have to add up to 5x. Those are where our x terms follow. And remember the product that you're going to see here is the product that you see in the diamond problem here, in the generic rectangle, excuse me. So 2x squared times negative 12. So 2x squared times negative 12 is negative 24x squared. That's where I got that, was from the generic rectangle multiplying diagonal. Because what's true about these rectangles is that the opposite diagonals, the two diagonals will have the same product. So now I guess I'm checking my head. What adds to 5x and multiplies to negative 24x squared? Well, they both have an x because they add to 5 x's. One has to be negative because we have a negative product, negative 24. So it's going to be negative 3 and positive 8. Because negative 3 times positive 8 is negative 24, and those two will also add to 5x. So those are my two corners that go in my generic rectangle. And now remember, for the final step, you start to fill in the outside of the generic rectangle. And that's the whole goal. That will give you my two factors, whatever is along the outside here. So let's check here. We have 2x squared. So in order to get 2x squared, it has to be 2x times x. The 2x should go here because of the 8x here. If the 2x was down in the bottom, it would affect this 3x, and we don't want that. So we'll have to make the 2x on the left. And then let's see, that top corner is going to be pretty easy to figure out as well, because x times negative 3 makes negative 3x. And remember, we do the bottom right. Let's see, to get 8x, I would have to use the 2x here and something, so it would be, that something has to be 4. So 2x times 4. And I check my final corner, my 12, negative 12, I make sure that that's correct and it works, because if I multiply the 3x and the negative 3 and the 4, I do in fact get negative 12. So we're good. We've got the right product here. So now I'm going to fill in my rest of my answer with the outsides of the generic rectangle. Those are my two factors. And now I have my final answer. I do want to check and make sure I didn't miss anything. This is fine, because anything out there might be a big number out in front there. But any of the sums, like the x plus 4, I want to check and see if that can be factored further, but x plus 4 is very simple. 2x minus 3, the 2 and the 3 do not have any common factors, so they are not, they're relatively prime, we call them, and they cannot be factored any further. So you are done factoring this. And the final answer is what you see here. 2x times x plus 4 times 2x minus 3. That is completely factored. All the common factors were pulled out, and we factored the polynomial. So example 2, I'm going to go a little bit faster, but this one does get a little bit harder. We did the same first step. We look for a common factor, and we see there's really none, because 2 and 3, again, they're relatively prime. It doesn't help me with the 32 and the 15, so there's no factors I can pull out. So now I'm stuck with this polynomial of the third degree, because it's got x to the third. This is not a generic rectangle that's only 4 squares. This will be my factoring tool, a generic rectangle, but I actually don't know how many squares it has. In fact, I could probably guess that it has 6. because it's x to the third. Okay, I'm not completely positive, but I'm going to test this and see if this works. So I'm going to cut it into 3 by 2. I can always add on more, so I could have started with a 2 by 2, but I'm looking for some factors. Now the good news is in chapter 2, I'm going to teach you some strategies for faster ways of doing this. Yes, some of you have already learned them last year. Maybe you saw some of these strategies, but this year you will for sure be mastering them. So let's take a look at how we're going to go about doing this. First of all, we take a look at our 2x to the third, our highest power. That always is we're going to put that in the bottom left every time. And then we're going to think about ways to multiply to 2x to the third. Well, it's going to be 2x times x squared. It could be x times 2x squared. I definitely want one of them to have x. So these are my two options right now. Honestly, it does not matter which one you try and which way you go. Okay, I'm going to just pick a direction and see if I can figure out what to do from here. So I'm going to just do 2x squared and x. Now the reason I put the x squared down here was so that I could have a larger polynomial along the bottom here. That leaves me room for an x term and a constant term at the end. So that's kind of one of the reasons I left that way. So let's take a look at what we will have. We have the next step is to make a guess. And what we're going to do is we're going to make a guess for this position down up here. And this is where we're going to run into some roadblocks, because we're going to find some answers that don't work. Here's how you're going to make that guess. What you want to remember is we're making a guess of something. This is going to be a constant, a number. Let's say we put the number 2 here. What I want you to remember is think to the future and where this is headed. Eventually this will definitely have an x squared term right here because of this x squared. This will also have an x squared term because our next lower factor is an x, because that's definitely going to be an x, times the original x that we have on the left. So the final term over here is going to be our constant. That's going to create our constant up here, the negative 15. 2 is not a good choice because the negative 15, I can't get a nice number that 2 goes into negative 15 with. Yes, 7.5 is right, but we don't want decimals. We want to factor completely with actual whole numbers. So what we're going to do is we're going to make a guess of something that goes into the constant. So all that work there was to help us realize that we wanted to go into that constant. So we make a guess, 3 or 5, it doesn't really matter. So I'm just going to make a guess of 3. Could have done negative 3, but let's try regular 3 and see if this works out. And I'll show you what I mean by working out. So let's take a look here. In this corner now, I have 6x squared. Now after I fill in that column, I want to think about what I want. Remember what I want here is for all of these terms left here to appear in the inside of this generic rectangle. So altogether I want 3 negative x squareds. So because of the 6x squareds that I have here, I'm going to create negative 9x squared. So altogether, I have negative 3x squared. So what follows is I lead myself on the path that will work for me, that will allow me to get what I want. So negative 9x squared, well, the way that I get that is this has to be a negative 9x, because that times x will give me negative 9x squared. And then again, I continue and I fill in the top because that has to be negative 27x. That's the only way to get that, because of 3 times negative 9. So again, before I fill in the next column, I think about what I want to appear. So I think about what do I want to appear right here so that I have the next term in my polynomial. Well, in order to get negative 32x's, notice you already have 27, negative 27, so I need negative 5x. So negative 5x has to go there in order for this to be factored. So again, I think about what has to be down at the bottom. Well, it has to be negative 5, because negative 5 times x is negative 5x. And then again, to get the top corner, we use the 3 times negative 5, we get negative 15. And what we notice is that it worked. This worked because, in the end, I got this polynomial on the inside of this big generic rectangle. Altogether, it totaled up to that. So this is one way to factor this polynomial. So one of our factors is x plus 3, because that's the column here. So far, my answer is x plus 3 times 2x squared minus 9x minus 5. That's my answer so far. And it's vanishing because it's not really my final answer. What's true is that x plus 3 is definitely a part of my final answer, but this guy right here can be factored further. So now we go about doing the next step, and we're going to factor further and factor the next polynomial here. So let's take a look at how to factor 2x squared minus 9x minus 5. This is going to be much simpler. We're going to have a single generic rectangle because it's only an x squared and not x to the third. Fill in our constant and our x squared term. In our diamond problem, we wanted to add to negative 9x because that's what the number of x's in the polynomial. And then finally, I'm going to multiply the diagonals, negative 10x. So negative 10x squared, excuse me. What multiplies to negative 10x but adds to negative 9x? And that would be negative 10x times 1x. And now I fill in the outside. This becomes much quicker. I'm going fast through this because I think it's something all of us should be able to do since we learned it in Algebra 1. And it looks like I have my final two factors. So my answer is x plus 3 because that was my first factor. And then it's 2x plus 1 and x minus 5. And that is a fully factored polynomial. And you're done. Okay, now I'm going to give you a chance to give this a shot on your checkpoint here. So remember, checkpoints are meant to give you a chance to try it on your own. And it's okay if you get stuck, as long as you've tried it. Your goal is to give it a shot all on your own. See if you can follow along. Don't be afraid to rewatch an example and hear again some of the hints that I have and the steps that you need to take to do this. But try this checkpoint and bring in your questions into class the next day.